So what we've got left is tonight, we're covering section 8.1 and 8.7. It's two separate, there's a bunch of stuff on matrices in the middle that we're not going to worry about covering. But 8.1 and 8.7, talking about systems of equations and systems of inequalities. And then next week, we take the test over these two sections. And the week after that, the final exam. And then you guys are all done. And some of you get to graduate then, right? And then you're all going to break into happy laughter and tears and good things, right? Okay. So let's go ahead and get started. Section 8.1, we are talking about systems of linear equations. And that just means if you graph them, you have lines that you're graphing. So the first thing we want to talk about is what kind of answers can we get? So if you think about graphing lines, there's only really three things that can happen. So let me take a look at these just visually here first. This is going to be dead because that cap wasn't all the way on, but let's see. Oh, it's just mostly dead. All right. Over there. So there's only three things that can really happen when you're talking about graphing lines. And so find something that works here. The first thing that can happen is kind of the most quote unquote normal thing, and it's the one we focus on the most, is if you draw two lines, let's say you have this line and this line, they might intersect in that one point. And that one point is the solution to a system if the equation of one of them is this and the equation of the other one is this. So where they cross, where they intersect, that's going to be the solution to our system. Okay, and we'll talk about what a system is in a minute, but that's the first thing that can happen. They can intersect in exactly one spot, and that's what we kind of look for most of the time. But then there are two special cases, more special cases. And one of them is you might have a situation where two lines are, what's the word for those lines? Anybody remember? Parallel. And they don't intersect. And if they don't intersect, this one had one solution where they intersect. This one has no solutions because they don't intersect. And then the third case, is this one. You might have two lines that actually completely coincide with each other. They're actually the same line, but they're described in different ways. So in that case, we have every point on this line is a solution to the system. And so you have infinitely many of them because they go on forever in those two directions. Okay, so these are the three things that can happen when we are talking about linear systems. You might have exactly one solution where the two lines intersect. You might have no solutions where the lines are parallel, and then you might have infinitely many solutions if the lines actually coincide with each other. So here's our first one. You might have exactly one solution, and that type of a system is called an independent system. The next one is you have a solution or a system that has no solution. That's the parallel lines, and that is called an inconsistent system. And then the last option is the one where they're actually the same line, and they have infinitely many solutions, and that is called a dependent system. Okay, so those are the only three things that can happen. It's got to be one of those three. Okay, and like I say, this is the one that happened that we kind of look at the most often, getting that one answer. But these are two kind of special cases that can also pop up. All right, so we're going to talk about two methods of solving these, and then we're going to practice these two methods. So the first method is called the substitution method. And the substitution method is based on exactly what it sounds like. You take something and you replace it, or you substitute it with something else. Okay, and you know, you think of sports and you think, oh, a substitute is a person that goes in place of somebody else, right? Now we have to be a little bit more particular in math because the two things that we replace have to be exactly equal. And that's not always true in sports. You might put in somebody who's maybe not quite as good as another person, or maybe they're better than the other person, right? Just depending on what's going on. So, but in math, when we substitute, we have to make sure two things are equal. So like trading 4 quarters for $1. That's okay because those things are equal, right? Or trading 2 10s for a 20. That's okay monetarily because those two things are equal. And that's what we have to do in math. They have to be equal, otherwise we're changing things, right? Not too many of you would trade like 250s for a 10. Oh, can I have your 250s and I'll give you a 10? Well, that'd be great. No, you wouldn't do that because they're not equal, right? So in math, they have to be equal. So, but here's the process we use for substitution. In order to substitute, we're going to solve for one variable. In other words, we're going to get either the y or the x, whichever one, by itself so that we know what it equals. So it'll be x equals whatever or y equals whatever. Okay, and we just need to do one of them so that we know what it's equal to. Okay. Once we know that and we've gotten one of those variables by itself, we do our substitution. We're going to replace. So if we got the x by itself, we'll replace the x in the other equation with whatever we know that x equals. If we got the y by itself, we'll replace the y in the other equation with whatever we found out that y is equal to. Okay? So when you do that, now you'll only have one variable left. And once there's one variable left, then we just use our normal algebra to solve. Okay? So that'll give us the answer or the value of one of the variables. Okay? Now, once we know the answer or the value of that one variable, we can plug that back in and solve for the other variable. Okay? So we call that back substituting. We'll plug it back in and we'll solve for the other variable. And when we're done now, we'll know the value of both variables, and that's our goal. We want to find the value of both variables. Usually we're talking about x's and y's, but it could be other letters as well. Okay? The second method we're going to talk about or practice is the elimination method. And the elimination method isn't based on replacing, but it's based on canceling things out. Okay? Eliminating them by canceling. So our first step in the elimination method is that we're going to adjust the coefficients. So we're going to have our two equations for our system. And what we're going to do is we're going to try and match up so that either the x's or the y's are exact opposites of each other. So like 3x with a negative 3x or 7y with a negative 7y. Because what happens there is when we get them to be opposites, we will add the equations together and one of those variables will cancel. Okay, so that's our goal. And we do that by multiplying. So we multiply one or both of the equations by an appropriate number so that the coefficients of one of those variables in the one equation is the opposite of the coefficient of the other equation. So that's going to be our goal. That's our main step for this one. Once we do that, we will add the equations like I mentioned, and that one variable will cancel out because you've got those opposites. And so then you'll have one variable left and you'll solve for that one. And then once you solve for that, it's just like the other one. We'll back substitute. We'll put it back in once we know that one answer, and we'll solve for the other variables. So we'll get done and we'll know both of them again. And you can use either one of these methods on any of these equations. So we're going to have two methods. I'll try and show you which is maybe the easier in certain situations than others. I have my personal favorite that I like better, but in certain cases, one of them is just going to be easier than the other one. Okay. So let's start off with this first one. And this is what we'll see a lot of times. We'll see a system, we'll have two equations, and those equations will have x's and y's or whatever variables, but usually x's and y's in those equations. So in this particular situation, I would say that substitution is going to be the easier one, even though that's not my favorite, but I think it's going to be easier in this case. And here's why I think that. If we look at this top equation, it's going to be really easy to get one of these variables by itself, and it's the y. Okay? And the way we can get the y by itself in this case is if I just add y to both sides of my equation, it's gone from there, and then we have 3x equals y. Okay, and that is our goal if we're going to use substitution, is we want to get one of the variables completely by itself, either x equals or y equals. Now, in this case, just to kind of think through this, in this case, the only one I would try to substitute for is the y. And the reason is this. If we were going to try and get the x by itself, eventually we'd have to get rid of this 3, right? Which means we'd have to divide by 3. And then you'd end up dividing the y by 3 and you'd have a fraction. And I don't want to have to worry about fractions if I don't have to. Okay? The same thing would happen here with this 5x. We would eventually have to divide by 5. And that's going to mess these up and make them into fractions or decimals. And then the same thing, if we had to divide by 2, it'd be fine over here, but dividing the 5 by 2, that's going to make that one into a fraction or a decimal. So if we can avoid doing that and avoid having those fractions, we'll avoid that. Unless you really love dealing with fractions, then make all the fractions you want, and it'll be, I mean, you can do it, it just makes it more difficult. Okay, so right now, we have done this work with the top equation, and we found out that y is equal to 3x. This is where we can now substitute, and we will substitute by plugging this information into this equation right here. So this equation will become 5x, just copy that down, plus 2, copy that down, but then we're replacing the y, n equals 22. What do we know that we can replace the y with? 3x, because we just found out that y is equal to 3x, right? It's like trading my 4 quarters for $1. They're equal, so I can replace them. I can trade them. So this 3x, I'll put it in a different color just so we can emphasize that that's what we did. We put in a 3x right here. Okay, does that make sense? And once you have this, notice now it's just all x's. So now we're just going to solve. So 5x, we can't do anything there yet. But this is going to be 2 times 3x, and what does that give us? 6x. And then equals 22. And then we combine like terms. So 5x plus 6x is 11x, right? And then what do we do to finish that one off? Divide by 11. So x equals 2. So we've got our first part of the answer, right? We needed to know what x is. Now we're going to figure out what y equals. And here's how we do that. We take this value right here and we plug it back into this equation that we already got by itself. Because now we know that y equals 3 times x. But what did we just find out that x equals? 2. X equals 2. So we're going to be able to put that in. And so that tells us y equals 6. And so here's how we write our answer. We write it like an ordered pair, like on a graph, 2, 6. And that tells us the x value is 2 and the y value is 6. And that's typically how they'll have you do that on your homework. Sometimes they might have parentheses and then have 2 separate boxes. But usually they just give you 1 box and you put in your parentheses and the comma in between. So just make sure you're paying attention to how they've got the answer set up, because different questions have it set up a little bit differently. Okay, and then the other thing you can always do with equations is if you want to check your answer and see if you're correct, you can always plug it back in. So if we put this in here, this would say 3 times 2 is 6, right? Minus y, which is 6. So 6 minus 6 equals 0. Is that true? Yeah. This one would say 5 times 2, so that's 10, plus 2 times 6, which is 12. So 10 plus 12 equals 22. And that shows us, yeah, we made them both true. And that's our goal, is to find the one value, assuming there is only one, that makes both of these equations true. Okay? Because that's our 3 options. There might be one value that makes it true, or there might be none, or there might be infinitely many. And like I said, most of them will come out so that there's one. It's really a special case if it comes out to be no solutions or infinitely many. But we will do some of those, so you'll see what happens, how you know it's one of those 2. So questions on that first one? Does that make sense, how we use that substitution method? Okay. Well, let us move on then. So, and then describe the lines. I should have mentioned this. Describe the lines. It is an independent system, but as far as describing the lines, you've got 2 lines. If you would graph it, you've got 2 lines that intersect right here at this point, that point 2, 6. So if you would draw the picture of those 2 lines, we're not going to, but if you would draw it, they would hit right there at that point. Okay, that's how it would look visually on a graph. All right, let's take a look at this one. This one is just another example. And in this case, I would suggest that our best option is going to be to use elimination. And here's why. if we want to try to substitute, if we were going to try and get the x by itself, we would eventually have to divide by 8, right? And do we see how that's going to make fractions over here? If we were going to get the y by itself, we'd eventually have to divide by 2. That's fine over here, but it's still going to give you a fraction there, or a decimal. Here, dividing by 12, that's going to give us fractions. Dividing by 3, again, it's fine over here, but it's going to give us a fraction over here. So none of them come out really nicely. Okay? And the goal is to try and pick the one that's the easiest if you're going to use that method. But maybe if none of them come out very nicely, then we switch to elimination. So here's our goal with elimination. Remember the goal that we talked about earlier. We're going to try and make either the x's to match up with opposite numbers or the y's to match up with opposite numbers. And the way we do that is through multiplication. Okay? So I would usually pick the smaller numbers just because they're easier to work with. What could I make both of these numbers equal to using multiplication? A 2 and a 3. What could we make both of those equal? 6, right? They can both, using multiplication, we could turn them both into 6s, right? And what would I have to multiply the top equation by to turn that 2 into a 6? 3. And what would I have to multiply the bottom equation by to turn that 3 into a 6? 2. Now, the other thing we want to check is we want the signs to be opposites, right? This is already a -2, and this is already a +3, so they're already opposites. We don't have to do anything. They're already, this is automatically going to be a -6 and a +6. Okay, but we do want them to be opposite signs. So let's take a look at what happens when we multiply these. When we multiply, we have to multiply everything by the 3. So on the top, 3 times 8x is going to be 24x. 3 times -2y is going to be -6y. And then this is the one that people usually forget. They forget to multiply this one. So it's going to be 3 times 5 is 15. And for some reason, I don't know if it's because it's on the other side of the equal sign or what, but people a lot of times forget to multiply that one by whatever number they're supposed to. Okay, so our first equation becomes 24x minus 6y equals 15. Are we good so far? We're going to do the same thing on the bottom. 2 times -12x is going to be -24x. 2 times 3y is going to be 6y. And then again, 2 times 7 is going to be, you got to remember that, 14. Okay. Now remember, our goal was to match these up so that they were opposites, right? In this case, something weird happened. Notice what happened with the first ones too. They also matched up as opposites, and that will happen sometimes. That's one of those special cases. So we're going to see what happens here. But what we do is we add these together. So what happens when we add 24x and -24x? They cancel out to be 0, right? So they're gone. What happens when we add the -6 and the +6y? They cancel out, so they're gone. And that means on the left-hand side, we have nothing left. We have 0. Does that make sense? Everything canceled out. On the right-hand side, we have 15 plus 14. What is that? 29. Okay? So here's what makes this a special case. All the variables are gone. Right? Usually we have a variable left and we eventually get x equals or y equals. Here they're all gone. That's what tells us it's a special case. That's what happens. So we are left with one of two options. We're left with either a true statement or a false statement when all the variables are gone. So is this true? Does 0 equal 29? No, not in this universe. Okay, so 0 does not equal 29. And so that tells us, is there any way to make 0 equal 29? And the answer is no. So this tells us there's no way to do this. There is no solution in this particular problem. Okay, so no solution to that one. And as far as what those lines look like, do you remember what the lines look like if there's no solution? They're parallel. Yeah, these lines, if you were going to graph these, if you're going to graph these two, they would be parallel lines. And that's why there's no solution graphically, visually. Okay, but as far as the algebra goes, if all your variables cancel out like this and there's no variables left to solve for, you're either left with something that's true or something that's false. And if it's true, then that's the special case where you have infinitely many solutions. If it's false, then you're, in this case, no solution. Okay? And it would end up that way whether you try to use elimination or substitution. You can use either method, and you should come up with the same answer every time, as long as you do it correctly. Okay? What questions do you have on that one? We kind of bypassed the elimination method because it just went away right away, but we got it started at least. All right, let's take a look at that one. It's an inconsistent system as far as the name of that type of system, but as far as the lines go, they'd be parallel lines. All right, let's take a look at these two equations. So, what option would you guys like to try here? Elimination or substitution? Substitution. Okay, if you want to use substitution, what variable would you try to get by itself? The y. So on the top or on the bottom? On the top. Okay. I'm going to suggest that's not probably the easiest one. You could do it, but our goal is going to be to try and choose the easiest one, right? And here's why I would say that's not probably the easiest. Because if we're going to get this y on the top by itself, we're going to eventually have to divide by 6, right? Does that make sense? Which is fine dividing this by 6, but over here, it's going to give us a fraction, right? So we can use substitution, but if we're going to, I would suggest go with the x instead. Because it doesn't matter which one you do. I saw you looking back. You're maybe like, well, we did y last time. Let's just do y again. It really doesn't matter which one we pick, but try to pick the easiest one. Okay? So if we're going to do substitution, which is fine, let's see if we can get this x by itself. So what would we do first if we're going to try and get that x by itself? Just algebra stuff. What would we do first to get that x by itself?
Add the 6y.
Yeah, we got to cancel out the 6y first. So the way we get rid of this and cancel it out is it's subtracting, we're going to add 6y. So that cancels. And that will give us 3x left on this side. The other stuff canceled equals, and this, I'm going to put the y first. I'm going to put 6y plus 12. Okay. Then what else would we have to do now in this step to get the x by itself?
Divide both sides by 3.
Correct. Divide both sides by 3. And when we do that, we have to make sure we divide everything on both sides by 3. Okay? So when we do that, we're going to get just x on the left-hand side, which is good because that's what we wanted, just x by itself. 6y divided by 3 is going to be 2y. And then 12 divided by 3 is going to be 4. Okay? Does that make sense? So now we know what x equals, right? We figured out that x equals 2y plus 4. So remember what we do with that? We're going to take it and we're going to put it in over here in place of this other x. So we're going to have 4, and then we're going to replace the x. Minus 8y equals 16. And again, I'm going to switch colors here just to emphasize we're substituting. What am I going to put in place of this x? Yeah, what we just figured out, right? X equals 2y plus 4, so that's what we put in here. Okay. So then, again, we've only got y's now, so we're just going to work through trying to get this y by itself. So the first thing we want to do is distribute. So 4 times 2y gives us what? 8y. And then 4 times 4 gives us 16. And then minus 8y equals 16. And if we combine like terms here, what happens with those two? They cancel out because one's a positive 8y and one's a negative 8y. So once again, our y's, everything disappeared again, right? The x's and y's. So look at what we have left this time. 16 equals 16. Is that a true statement? Yes. Is there any way to make it a false statement? No. 16 always equals 16, right? So just like the other one, 0 equals 29, we couldn't make that true. 16 equals 16, we can't make that false because all the variables are gone. So this is a case where you have a true statement. This is infinitely many solutions. And again, graphically, what does that look like? What it looks like is we've got these two equations are actually the same line. So they're two lines that coincide completely with each other. Okay. Now, the issue that we have here, and this can be a little tricky sometimes, but I want to make sure you see it so that in case you have to do it on your homework, you're ready. What we typically will do in a case like this is we still want to describe the solutions because we know there are solutions, right? The difference is there's not just one that we can say it's 7, 3. We've got to describe them. What do these solutions look like? And so here's what we do. We typically will take one of the equations and usually we'll get the y by itself, but we already got the x by itself, so I'm just going to use that. Okay? But typically we'll take one of the equations and usually we'll choose an x value. And once we choose an x value, that will determine what the y value has to be. But in this case, since we already solved for x, we're actually going to choose a y value. So we're going to say y can be anything. Okay? We can pick any number we want for y. But once we pick that, and we plug it in, then x has to be 2 times that number plus 4. Okay? Now, like I said, if it was me, if we hadn't have done substitution already, I would usually just solve for the y and put it like in slope-intercept form, like we would if we were going to graph it and get the y by itself. So we would have a fraction, but we don't have to do anything with it after that. And you'll see our answer, I do have the y by itself. But this is just describing it. So when you have you've already done this part, whatever's over here, that's what you get to choose. Okay, so if the y is over here, you get to choose the y. Okay, and once you choose that y, then you plug that in, and then the other one, the x in this case, is 2 times that number plus 4. So for instance, if I wanted to know, okay, what if x is 1, or sorry, what if y is 1? Well, 2 times 1 is 2, plus 4 is 6. The ordered pair there would be 6, 1. That's a point that is a solution to our system. Okay? What if x or y is -5? Well, 2 times -5 is -10, plus 4, that's going to be -6. That would be another solution to our system because there's infinitely many, right? We just need to know how to describe them. So this is how we describe them. And again, I can't remember for sure if there are any like that in your homework. I would have to double check. But if you get to some like that, that's how you describe it. It may just be, if I remember, it may just be that you say, oh, there's infinitely many solutions, and then you're done. I can't remember. That's one of the bad things about teaching this class in 2 different places, because your assignments are slightly different because I see them every day. So I make their stuff a little bit harder than your stuff because I only see you once a week. So anyway. And you'll notice, like I said, this one is described a little bit differently because I chose an x value, and then this is what the y value would look like. But these are actually the same answers. They're just going to look different. Okay. But again, there are infinitely many solutions. It's a dependent system because they're actually the same line. All right. Questions on that one? Do we understand why it's infinitely many from right here? It's because the variables cancel out, so it's a special case, but it's a true statement this time instead of a false statement. Okay. All right. So we talked about these fractions and how we don't particularly care for the fractions, but sometimes they give us fractions in the equation. Fortunately for us, we don't have to leave them there. Okay, and let me show you how to take care of these fractions. What we want to do is we want to get rid of these denominators, the 3 and the 5. So remember how we can multiply both sides of the equation by the same value and we haven't changed the solutions of the equation? And we just did that like on some of those other problems when we did elimination. We're just going to use that in a different way. What could we multiply this top equation by to make sure that the 3 and the 5 will both cancel out and there won't be fractions anymore? Maybe think of anything we could multiply by to make both of those cancel out. I'll let you ponder for a second while I sip some Dr. Pepper. Let me ask you something else. What if this one wasn't there and I just wanted to cancel out this 3? What could I multiply by? Couldn't I just multiply by 3? Like if it was divided by 3, multiply by 3 to cancel it out? That makes sense. Like if you saw this equation, oops, just x divided by 3 equals 8. And you were trying to get the x by itself, how could you get rid of that 3? Once you multiply by 3, it's the same thing here. If we want to get rid of this 3, we're going to multiply by 3, right? But we don't just want to get rid of this 3, we also want to get rid of this 5. So we'd also have to multiply by 5, right? But we can do that all at once if we multiply by 15. That's 3 and 5, right? So we can multiply by 3 and 5, or 15, and that will take care of those fractions. So let's see how that works. So if we multiply by 15 right here, and you may want to get your calculator if that's helpful for you, but to get rid of these fractions, what is 15 times 2/3? 10. So this becomes 10x. And notice the fraction's gone, which is what we want. We don't want that fraction there anymore. What happens when we multiply the 15 times negative 1/5? Negative 3. So it'll be negative 3y. And again, don't forget this. We're still going to multiply 15 times this 3 over here, even though it's not a fraction. What's 15 times 3? 45. Okay? So we have succeeded in getting rid of the fractions in our first equation, right? So now I'm going to give you guys another shot. We want to get rid of the 2, and we want to get rid of the 4. What could we multiply by that would get rid of both the 2 and the 4? 8. We could use 8. Is there anything smaller that would work? Because I know what you did. Tell me what you did.
I multiply 2 things.
Yeah, if I multiply by 2 and 4, it'll cancel them both, right? And you're exactly right. But there's actually something in this case that's smaller that we can multiply that will still cancel them both. Not 2, because that won't cancel the 4. I know, it's so tricky. I'm making you guys think on Tuesday. We can actually multiply by 4, right? Because 4 times a half is 2, right? So that will cancel. And then 4 times 3/4 will cancel the 4 also. But let's say you didn't see that, and you did see the 8, because that makes sense, right? 2 times 4. So let's multiply by the 8, because it will work either way. It'll just be smaller numbers if you use the smaller value. So what is 8 times 1/2? 4. So this is going to be 4x. Then what is 8 times 3/4? Yeah, it's going to be 6y, right? And then 8 times 1 is 8. Okay, so now we have our new system and there's no fractions anymore. Isn't that a lot nicer looking than the other one? So you can do it. Okay, you can do it with fractions. But I'll tell you, it'll take you a lot longer and you're more likely to make a mistake with the fractions. So I'd say just get rid of the fractions and now work with this. Okay, so when we're doing this, substitution is not going to be a good option. Just looking at dividing by 10, dividing by 3, dividing by 4, and dividing by 6. Substitution is not going to work out nicely for us. So let's try to do elimination. And looking at the x's or the y's, which one do you think would be easier to turn into the same number? Because like I said, with these methods, a lot of times it's what's easier. We can try to do what's easier.
The negative 3 and 6.
Yeah, the negative 3 and the 6. We can turn the y's both into what number? can't we actually turn both into 6s? Because the bottom's already a 6, right? And what do we have to multiply the top by to turn it into a 6? 2. You don't have to multiply both of them. If you can get away with only multiplying one, that's even better. Okay? So they're already different signs, right? One's positive, one's negative. So we're just going to multiply the top by 2. And I'm going to write it down here. So we're going to have 20x minus 6y equals 90. And that's just multiplying the 2 by each of these values. Make sure you get all 3 of them. And then the bottom we didn't have to change. So 4x plus 6y equals 8. And then we want to add this. So what happens when we add the 20x and the 4x? What do we get? 24x. And the 6y's, they're opposites. They're going to cancel out, right? And then 90 plus 8?
98.
98. And then how do we get the x by itself then? Yep. Divide by 24, divide by 24. And unfortunately, our final answer is still going to be a fraction. Let's see, that's 49 over 24. No, 49 over 12. Is that it? Is it just 49 over 12? Okay. And again, when you put these answers in on the computer, most of the time they want exact answers and they may specifically say use a fraction. So you just have to leave it as a fraction. And it doesn't allow you to make it a mixed number. So you just have to leave it as 49 over 12. You can't make it 4 and 1/12. Okay. So that's our x value. And then what we want to do is we want to plug that back in to figure out the y value. Now we haven't had to do that yet with elimination. But my suggestion would be plug it back into one of these that doesn't have the fractions. And usually choosing the one with the smaller numbers is a good option. It's not always. This is just a general hint. But I would plug it into that bottom one that has the smaller numbers. Okay? And when we plug that in, it's going to say 4 times 49 over 12. And then plus 6y. And then equals 8. Does that make sense what we did? We took this, the x value that we just found, and we put it in place of the x in our equation. Okay. So now we have our equation that just has y's in it, and our goal is going to be to get that y by itself. So first step, multiply these two. It ends up being 49 over 3. And we didn't do anything else. Okay, and here's where, again, I would say just get rid of the fraction. What can we multiply by this time to get rid of that fraction? This time it's easier because there's only one fraction, right? Just multiply by 3. Does that make sense? We were trying to get rid of this denominator. So we can multiply by 3. And multiplying by this is just going to turn that into 49. Multiplying by this is going to make it 18y. And then multiplying by this is going to make that 24. And again, once those fractions are gone, this equation doesn't look nearly as intimidating. So what would we do next? Subtract the 49. So this leaves us with 18y and negative 25. And then our last step is
Divide both sides by 18.
yes. Exactly. So y equals negative 25 over 18. And that tells us that our ordered pair, our answer is 49 over 12 for the x value and negative 25 over 18 for the y value. So even though our answers are fractions, do you notice we didn't have to deal with really any fractions in the actual work because we just got rid of them each time? And that would be my suggestion. I mean, unless you really love fractions, just go ahead and get rid of them so you don't have to mess with them. Okay? It's going to make it probably the easiest. But again, if you want to keep them, you will get the same answer if you do all the math correctly. It's just easier to make little mistakes when you're trying to work with all the fractions and stuff. Okay. So again, our strategy, get rid of the fractions, multiply by 15, multiply by, we did 8, and then come over here, and then we used elimination, turn them both into 6s, cancel, get this, solve for the first one. And once we solve for the first one, we plug it back in, and then we were able to cancel the fractions again and solve again. Okay. So hopefully I did all that little math right. There we go. Good. Any questions on that one? So even if they look scary, a lot of times we can make them look much nicer by just getting rid of those fractions. Because like I said, even for me, and I've been doing math for a long time, this definitely looks worse to try and work with than this does, right? And so if I can turn this into this, it's much less scary.
So for when you want to get rid of the fraction for the initial thing, multiplying the denominators, will that usually like?
Yeah, it will always. And like I said with this, so if you just take the 3 and the 5, multiply by both of them, so it's 15, multiply by the 2 and the 4, multiply by 8, that will always work. It's not always the smallest thing you can multiply by.
Yeah.
Like in this one, I said we could have multiplied by 4, and that would have given us 2x plus 3y equals 4. And actually, then the 3y's would have matched up right away, and we could have canceled right away too. But it doesn't matter as long as we get to that answer, right? Notice we got the same answer, even if we did it a slightly different way. So yes, if you're just, what will work every time? Yeah, if you multiply by both of these on the top and then both of these on the bottom, that will work every time. It just may not be the smallest number you can multiply by. Okay. All right, well, let's take a look at this one after I erase all these scribbles all over the place. And once again, we have fractions on the top, but no fractions on the bottom, so that's nice. So let's take a look. What could we multiply that top by to make it so that there are no fractions there? Any ideas? 6 would be a great option. So we're going to multiply by 6. And multiplying 6 times a half gives us 3x minus, and then this is 6 times a third is 2y. And then don't forget this, 6 times -1 is -6. Okay, does that make sense? Now, be a little bit careful here. Notice what I've done here to not really trick you, but to get you to pay attention. What's weird about this one?
You have to.
The x and y are like backwards, right? Usually we put the x first and the y second. So we're going to switch that around when we rewrite it. We don't have to do anything else, but we're going to put the -3x first and the +2y second, and then equals 6. Does that make sense? Does everybody see that? Because we want things to be lined up as much as possible. So if we have to switch them when we're doing that, that's fine. Well, notice the x's are ready to go, right? We can use elimination here. So let's just add these together, and the x's cancel. What happens with the y's? They cancel also. So what do we have left over here on the left-hand side? 0. What happens over on the other side? They cancel. So we have 0. So all our variables are gone. Special case, is this true or is it false? True. So what does that tell us? It's either no solutions or infinitely many. Which one is it? Infinitely many. I heard you guys saying it, but I just was in the middle of a sentence when I heard it. So infinitely many solutions. Okay. And then once we've got that, we want to go ahead and we want to describe those solutions. So we did not use substitution this time. So what I would say is let's just go back right here and let's take that and let's get the y by itself. Okay, let's put it into slope-intercept form. That's what we would typically do. So what will I have to do first to start getting this y by itself?
add 3x on both sides.
Correct. Add 3x to both sides of our equation. This cancels, so 2y equals 3x plus 6. Then what else do we need to do? Yeah, divide by 2. And remember, we're dividing everything by 2, so y equals 3/2 x plus 3. Okay, so that's the information we need. And remember, to describe our solutions, we get to pick any x value we want. So again, I usually use a. I think in the answers I put t for some reason. But we usually can use any variable we want. So I'm going to choose a. And then once we've chosen that a value to be the x, right? That's the first thing is the x. We just plug that in, and then y has to be 3/2 times a plus 3. And that's our description of all the solutions. You can pick anything you want for x, but once you do, this has to be the y that goes with it. Okay? And so that is, again, like I say, I don't remember why I use t's, but anyway. Same thing, right? You can use any variable you want. Does that make sense how we do that? But you only have to do that if you get that infinitely many solutions, because you still have to try and describe your answers. All right? Before we go on, any questions? All right. Guidelines for modeling. And we are not talking about like models who wear fancy clothes and things like that. In math, when we talk about modeling, we're talking about making up an equation that represents a situation in real life or from whatever problem we're dealing with. Okay? So the first thing we want to do when we are modeling with systems is we want to identify the variables. Usually that means usually the question tells us what the variables are. Like it might say, how many of this and how many of that? Well, that tells us those are the two things we don't know. We'll probably use those as our variables. Or how fast is this and how fast is that? Well, that's the two things we're trying to figure out. We're going to probably use those as the variables. So identify those quantities that we need to be found, or sometimes they could be given information. Express the unknown quantities in terms of those variables. So like I said, if we pick what we don't know, we just say, well, this one is x and this one is y, or whatever letters we want to use. Then we set up our system of equations. This is probably the toughest part right here, is to come up with the equation. Because all these before, you were just given the system, right? Here, we're going to have to make up our equations using those variables. And then we solve and interpret the results. So most of our attention is going to probably be step 3, trying to come up with those equations. Is that already written on your notes? So we're good. Okay. So example 6 says a local buffet, and I don't remember if these are even on, they are on your paper? Okay, good. A local buffet charges $7.50 per person for the basic buffet, and then $9.25 per person for the deluxe buffet. If 27 diners went out to eat and the total bill was $227 before taxes, how many chose the basic buffet and how many chose the deluxe buffet? So notice the two questions that get asked. How many chose the basic buffet and how many chose the deluxe buffet? That's what we're trying to answer. That's a really good thing to set up as our two variables, right? Does that make sense? So I'm going to be very creative here, and I'm going to choose B to represent the basic buffet, the number of people who chose the basic buffet. Okay. And then I'm going to go over here, and again, I'm going to be very creative, and I'm going to say, let's let D be the number who chose the deluxe buffet. Okay. So now, once we've identified that, what we want to do is we want to use those variables to come up with our equations for our system. And sometimes that's easy, and sometimes it's a little bit more difficult. So let's start with the easy part. At least I think it'll be easy. $27 diners went out to eat. what equation can we come up with from that part of the statement? If this is the number who chose the basic buffet and this is the number who chose the deluxe buffet, what equation can we come up with from that part of the statement? 27 diners went out to eat. Okay, let me ask you another question. If I told you that 20 of them chose the basic buffet, how many are left to choose the deluxe buffet?
7.
7, right? Well, what if I told you that 10 of them chose the basic buffet? How many are left to choose the deluxe buffet? 17. Now, how do you know that? Two different people answered that question. How did you know?
We subtract the number you gave from the total.
And the reason is because we know how many people went, right? 27 people. And here's what that tells us. The number of people who chose the basic buffet plus the number of people who chose the deluxe buffet has to be equal to 27, right? You guys know that, but the hard part is getting it down in an equation, right? Because when I asked you the question in words, you guys both answered it. Okay? So B plus D equals 27. Now here's another thing you know, because you've all probably purchased something or purchased multiple items of the same thing or gone out to eat with somebody else. So let's break it down here. Let's say that I go to Burger King because I happen to like Burger King. If you don't, that's fine. It's just whatever. So let's say that I go to Burger King and they're running some deal and it's $4 for whatever that deal is. And I'm going to get one for me and I'm going to get one for my wife. How much do I have to pay if I get one for each of us?
Well, 8 plus taxes.
Okay, let's say before taxes. But yes, 8, right? And the reason is because it's 4 times 2. But what if I bring my kids along and I've got 3 kids? So now I'm paying 4 times what? 5, because I've got to buy it for each of us, right? So it's the price times how many people. Does that make sense? So now let's go to the money equation. Here's the money equation. It says the total bill was $227. That make sense? If B number of people got the basic buffet, how would we figure out how much money they spent? Because how much do you have to pay for each person who got the basic buffet? $7.50. So does it make sense? It's the price, $7.50 times the number of people who got that. Okay. And very similarly, what do I have to pay for the people who got the deluxe buffet? $9.25 times D, right? And that total is $227. Okay. So like I mentioned, most of the time, the majority of your thinking and the majority of your work goes into this part, coming up with that equation. But once you've done it a few times, you're like, oh, I've seen a problem kind of like this before. I can maybe work this around or whatever. So I don't know. Here's our system. Looking at this, what method would you try to use? Elimination or substitution? Elimination, okay? And if you're going to use elimination, what would you do? Because remember, elimination, we want to make one of the variables match up as opposites, right? So we want to turn these so that they're both coefficients are opposites, or these so that the coefficients are opposites. And we can do either one. So if you're going to use elimination, what would you do? So if I was going to do the b's, what would I have to multiply by to make these the same? You'd have to multiply by -7, or I guess I shouldn't say the same, opposites, So you'd multiply by negative 7.5 up here, right? And that would cancel out the b's. If I was going to cancel out the d's, what would I have to multiply by? Negative 9.25, right? So you've got those two options if you're going to use elimination. Okay. I guess if I was going to do that, I'd use the smaller one, right? Just keep the numbers as small as possible. So let's multiply by negative 7.5. And I'm going to do that, and I'm going to put this right down here. So I'm going to have negative 7.5b minus 7.5d equals, and if somebody can help me out, what is 27 times negative 7.5?
Negative 189.
Negative 189? Okay. Is everybody getting that same thing? Who tried it? Okay, and then if we're going to use elimination, remember we're going to add these. So the b's cancel out. 9.25d minus 7.5d gives us what? I think it's 1.75, but if somebody could double check that for me, I would appreciate it. Is that right? Yeah. Okay. Equals, and then subtracting this one, I think, is it 38? Somebody could double check that one for me too. Yes, no, yes. Okay, got a yes. All right, good. My math skills are working tonight. Okay, and then what do we have to do to finish to figure out what D is? Divide by 1.75. That one I'm not going to try and do in my head. I maybe could, but it would use too much brain power tonight. So if somebody could do that for me, 38 divided by 1.75, what do we get for D? And hopefully it comes out evenly, because we don't want any thirds of people going to the buffet.
$21.7.
Oh, something's wrong here. Did we mess something up? Is that what everybody got? 21.7? Oh, something's wrong. Do you see why something's wrong? This is number of people, we can't have a fraction, right? Does that make sense? So let's look. What did I do wrong here? 27 people went. It was 227, 925, 750, basic buffet, deluxe buffet. Negative 7.5, negative 7.5. And was everybody,
Oh,
were we?
it's 2. Or 1.75 is 2. It's 2. Wait. No, wait, no. Oh my God, I'm dumb.
No, we're just trying to find our error here. Is this number right? The one, the negative 189, 27 times negative 7.5? If someone can double check that just to make sure. Trying to find our error here.
What is it?
227 minus, or no, the 27 times negative 7.5.
Got 7.5 on the lower subtraction on the 9.25 minus 7.5.
And you got what?
7.5.
Mm,
Not ridiculous.
JK. We're JKing now. All right, you guys are not helping me here. I'm going to have to pull out my, here, let's still, I think we might be this number, but I could be wrong. Man, we're coming up with all sorts of weird numbers now. Okay, so 27 times 7.5. Okay, I've got 202.5. Is that, okay, so that's where our error was. Let's fix that up. I had at least a couple people agree with me, so that's a good thing. So 202.5. And that's going to make this, because we were, and it's negative. So that's going to make this, when we subtract it, 24.5, I think. I better double check. Make sure my math is right. Okay, 24.5, and then we're dividing by 1.75. Whew, much better, 14. So D equals 14. So 14 people went to the buffet and chose the deluxe buffet. Now, probably without even doing a whole lot of math, how many people must have chosen the basic buffet? Not 3.
Oh,
13, right? Because we know the total is 24 or 27. And we're all discombobulated today. Okay, so 13 people chose the basic, 14 people chose the deluxe, and yeah, there we go. But you know what? Sometimes we do punch a number into our calculators wrong, and we may have to go back. But honestly, like I said, when we got whatever it was, 21.6, I was like, something's wrong there, right? Because you can't have 0.6 of a person going to the buffet. That doesn't make any sense. So we do have 13 basics and 14 deluxes. I know we had to go back and fix something on that, but how does that one look? That kind of makes sense. And like I said, usually, and we actually had trouble down here, but usually it's this first part right here that's going to take most of our creativity of coming up with an equation for that. Any questions? All right. Example 7, last one on this one, I think. All right. A 10% salt solution is to be mixed with pure water to produce 75 gallons of a 3% salt solution. How much of each are needed? So again, here's our question. How much of each are needed? So that's where we're probably going to get our variables from, if that makes sense. What are the two things we're talking about here? How much of each? What is it asking us about? How much of each what? One is the salt solution. Okay, so let's let, I'm just going to go with X and Y this time just because I don't like the letters. I don't like using S's because they look like 5s. So X we're going to let be the amount. We'll say gallons because this is in gallons. So this will be gallons of 10% salt solution. Okay, and what was the other thing we were mixing together with that salt solution? Pure water, right? So we'll let Y equal the gallons of water. Everybody okay with those two selections, those two choices? Does it make sense why we picked those? Because that's the two things we're looking for. All right. Okay, so let's see what we can come up with here. I'm looking at this, and I'm going to let you guys look at it for a second. Does anybody see something that can help us come up with our first equation? Or an equation? It doesn't have to be a first or second, but I mean, it's the first one. We haven't done one yet, so it's the first one. I'll give you a hint. A lot of times these deal with the totals. You think about that last problem, it was total number of people, right? We had an equation about the total number of people, and then we had an equation about the total amount of money. Yeah, the 75. And what is that? The total amount of stuff altogether, right? So the 75 gallons, they're going to produce 75 gallons of solution. Okay, so what does that mean? Well, it means when I put the gallons of the 10% solution together with the gallons of the water, the total is supposed to be 75. Right? So there's our X plus Y equals 75 gallons. Does that make sense? Now, the other piece of that is we've got to deal with the salt. And a lot of these markers do not work very well. That's why I bring my own sometimes. Well, I bring my own all the time. Just don't always use them. That one's completely dead. All right. All right, I'm going to go to this one. We have to deal with the salt. Because the other information they gave us was how much salt there was in each one, right? So here's what we've got to come up with. the first one we know is 10% salt solution. That means out of the solution, 10% of it is salt, right? So 10%, and we did something like this before. How do we turn that 10% into a decimal so that we can work with it in our math numbers? What is 10% as a decimal? Move the decimal twice, so it becomes 0.1, right? 0.10, just 0.1. So 0.1, and that's the x. 0.1 times the x, that's how much, oh, let me put it up here closer to this one. 0.1x, that's how much salt is in the 10% salt solution. Plus, how much salt is in the y? Well, y is the gallons of water. How much salt is in there?
3%.
That's, you're one step ahead of me. We're not there yet. But just the water, if you're looking at just the water, how much salt is in the water? Because it says it's not just water, it's pure water. So how much salt is in there? It's a little bit of a trick question. There's none, right? There's no salt in pure water. That's why it's pure water. So we actually have 0 y equals, and here's where you're coming up. We've got that 3% of the total, right? So the final solution, 3%, remember that's going to be 0.03. 0.03% of what? Or not 0.03%, but 3% of what? 3% of that total 75 gallons. Does that make sense? So the idea here is you've got this bunch of 10% solution. You've got pure water. When you mix them together, you know, this one has none, this one has some. When you mix them together, the concentration is going to be lower, right? It's not going to be as high as the 10, and it's not going to be as low as the 0. It's going to be somewhere in between. Does that make sense? And so that's what's going on here. We're mixing the 10% with the 0%, and we're going to end up with 3%, and that's 3% of the total, which is the 75 gallons. So the question is, how much of each do we use to make that happen? Okay. So we've got this one. This one looks really nice. This one looks kind of messy. Let's simplify it a little bit. We've got 0.1x. What happens when you multiply anything by 0? It goes away. It's 0, right? So we don't even need the y. And then if somebody could help me out, 0.03 times 75. Is it 2.25? Or something around there?
Yeah.
2.25. Okay. Okay. And actually, this is really nice because notice this one already only has one variable, right? So how would I get this x by itself? Yeah, divide by 0.1. So x equals, and this ends up being 22.5. So that 22.5 up here is the amount of gallons of the salt solution. Once we know that, how will we figure out the amount of gallons of water that we have to use to mix with it? Yeah, probably going to substitute right back up into here. And we would know that 22.5 plus y equals 75. Or, I mean, if you're just thinking about it common sense, right? We have to subtract like we did with the people at the buffet. Okay, so, and if you look at it mathematically, that's what you're going to do also. Subtract 22.5 from both sides. And it looks like we should get, what, 52.5? Is that right? Yes, no. I think that's right. Okay, so 52.5 gallons of water and 22.5 gallons of the 10% solution. Okay. So some of these just take a little bit of practice. So you're gonna get some practice. Some, I mean, a lot of them on your homework are just solve, solve, solve. But there are a few like this where you get to practice a little bit on making up some equations on your own. Any questions on this one? This one is a little bit different. And everyone here, the thing is, everybody's like, oh, well, I haven't seen these types of equations. Well, there's really no way to do every type of word problem because there are infinite numbers of types of word problems. So you just kind of get strategies. You know, you're going to look for two basic topics. In this case, it was total amount of gallons of stuff and then salt solution. The last one, it was total number of people and then the money they spent. It's different on each time. So, all right. So any questions there? All right, that's the end of that one.